live again. I'm going to give it a minute because we're a little bit early on this. So I'm just going to give it just a moment for people to log in and join us. I sent out an email since the last lesson. That email that I went over in the previous, while going over the previous lesson, I sent that out. Your next class, you will have tests to pick up at the school. It will be, I believe it'll be 3 tests. I will have to check the schedule and everything. The past 2 things that we're going over now, and then the thing that we're going to go over next class, which will be Transformers, I believe. So be prepared for that. Have all the, you know, I'll be ready to drive to the school. If you live more than 50 miles away from the school, we can mail you the test. Just so you're not driving 2 hours to get your test, because that's a little unreasonable. All right, we are gonna get started now, and I do apologize if you hear stuff in the background. I don't think you'll be able to, but if you can, I apologize. Alright. Without using any exceptions, generally the smallest aluminum conductor permitted to be installed in parallel is blank gauge. So we're going to use our code book on this, and we'll use our code book, go to the index, look up conductors in parallel. So you're going to look up conductors as the main, and then under conductors you're going to look up the words in parallel. Or probably just parallel. And that should direct you to Article 310. 310.10H1 is where that's going to send you. And the smallest conductor that can be made in parallel is 1/aught. I don't believe the aluminum part has, I don't think aluminum changes anything for actual parallel conductors. Which of the following tables provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius, where not more than 3 current-carrying conductors are installed in a raceway cable or earth, based on an ambient temperature of 86 degrees Fahrenheit. If you remember last class, we went over that table. 310.15b16. You should be pretty familiar with that table at this point. We have used it a lot. Alright. When insulated conductors or cables are used where exposed to direct rays of the sun, they must be listed and marked as being sunlight resistant or be covered with insulating material such as tape or sleeving that is listed and marked as being sunlight resistant. We're going to look up conductors, indirect sun. This is true. To look that up, you will look up conductors and then indirect sun, and that will give you the 310.10D. Conductors used for direct burial applications are generally required to be a type identified for such use. This is pretty obvious, but I would look up conductors for direct burial. Like the answer to this one is pretty obvious. Of course, they have to be identified for direct burial. But look up conductors, and I'm going to look this one up because I don't think I've looked this one up this week. Conductors, and then direct burial. It's not. Burial is not. Buried. There it is. Conductors, then buried. And that's 310.10F. Sends you right there. Alright. Where more than one ampacity applies for a given circuit length for conductors rated 0 to 2000 volts, the highest value is generally required to be used. Let's see. Okay, so what this question is talking about is if you're using like number 10 and number 12 in the same run, just because you're using the wire that you have, that that run has to be rated at the lowest ampacity available. So if you're using number 10 and number 12, you have to rate it as if you use number 12 the whole way. Where run in parallel in separate cables or raceways, the cables or raceways with conductors are required to have the same number of conductors. So this is going to be back in that parallel section, so conductors in parallel. Go back and read some more about it. And yes, you have to have the same electrical characteristics on everything you're using in parallel because it's going to cause issues with the currents on the different conductors if they have different electrical characteristics. Remember, whenever we were doing DC theory and we had parallel things, if they had the thing with the lower resistance got the more current. So if you have two different resistances, one of those wires is going to be having more current on it. Okay, a neutral conductor. Okay, so this is going to have to do with when do you count the neutral conductor when you're calculating ampacity. If you go to 31015B5, that is actually titled neutral conductors. So it sends you to 31015B3A. And if you look at the title, or if you look at the table 31015B3A, that's a lot to say. If you're looking there, 31015 is ampacities for conductors rated 0 to 2000 volts. And if you look up adjustment factors, so B is tables, and then under adjustment factors you're going to have neutral conductor, and it will describe when you count and when you do not count the neutral conductor. You do not need to count it whenever it is only carrying the unbalanced current from the other conductors in the same circuit. Which will be the general use case for the neutral conductor. Let's see. Except is permitted elsewhere in the NEC, the minimum size of copper conductor. Oh, excuse me. Rated 0 to 2000 volts, according to Part 3 of Article 310, conductors for general use is 14 gauge. So, I would look up conductors. almost there. Conductors, and then I would look up something like minimum size. Minimum rating and size, not there. That's not the correct spot. Uh, let's see. That's weird that it's not at minimum size, because that's a completely wrong location. Um, so passes of properties? No. Hmm. I'm not seeing a keyword that will send me there. Oh, what the hell was I looking at? Minimum rate. Grounded conductors minimum rating and size. That's why. Okay, if you look up the actual minimum size location, it gives you a bunch of different locations. We are talking about just general conductors, which will be in chapter 3. So that should narrow down your uh, spots. And 310.106a is the correct location to look at. So conductors and minimum size than 310.106a. What I had seen was a completely different minimum size. I'm glad I wasn't looking in the complete wrong spot. Uh, Type THHW has a maximum operating temperature of 75 degrees Celsius in a wet location and 90 degrees Celsius in a dry location. So if you look at table 310.15, no, 310.104a, I believe is the table. It's all the insulation properties. And a good rule of thumb is any wet location wire, so any insulation with a W in the name, has a 75 degrees in a wet location and 90 degrees in a dry location. If it has a -2, like if it's got the name and then -2, then it's 90 degrees wet or dry. If it's allowed in a wet location, it's 90 degrees. -2 basically means 90 degrees, and the if it does not have the -2, then it's 75 in wet and 90 in dry. One of the principal determinants of a conductor operating temperature is that the thermal insulation that covers or surrounds conductors affects the rate of heat dissipation. So that's how they determine how the conductor temperature is. It's about how much heat the conductor can dissipate. All right. So let's check our results table. Melinda and Kara are having issues apparently. So let's go ahead and end our current activity and launch the second to last quiz of the day. Alright, you guys have good luck with this new quiz, and I will see you guys in 2 hours.